So yesterday we talked about metrics and all of that stuff. So we talked about NumPy, how to create a NumPy, how what are the different functions, how to do slicing, matrix. We talked a bit about images and how
Yes,
images are actually stored in a computer in the form of a matrix and all of that. Right. So the last thing I could remember is I was just thinking of creating two matrices of different dimensions and doing some operations. So what I'm thinking is instead of doing that, let's jump directly into pandas because essentially that one will be more important. Try out these options. Like here, you know how to create a matrix. Matrix addition. So one matrix plus another matrix will be an addition. If so, addition and subtraction will be straightforward, but multiplication and division will happen in a particular way. So matrix multiplication happens in a certain way that number of rows in one. Okay, let me tell you in short. So in that case, let's say this is matrix one is equal to np dot import. Now this NP is not working because that session had closed. So I have to reopen it. So then this NP will be reassigned. So yeah. So matrix one is equal to NP dot array. Now what I want is I want a two-dimensional array. 1, 2, 3. This is one and I want another. So it will be a list of list. 3, 4, 5. And this will be like, so matrix one, how will it look like? Yeah. So it has, so what is the shape? So if I put shape, it will tell you it has 2 rows and 3 columns. So if I do this, it has 2 rows, 1, 2, 3 is one row, 3, 4, 5 is another row, and the columns are the vertical ones. 1, 3, 2, 4, 3, 5. These are the 3 columns. So this is one matrix. I have to create another one. Let's copy and quickly see if I can. Let's do it like this. 1, 2. This is 1, comma. Then 3, comma 4. This is another, and then 5, comma 6. So if I do this, how the matrix 2 will look like? Just little bit different compared to matrix 1. So the matrix 2 goes like it has 3 rows and 2 columns, so just opposite to what it had. Now in matrix format, now just understand this thing. You can ignore rest of the things. Just understand how the multiplication works, because this would be needed if you go for convolutional neural network or image processing in near future. This will be beneficial. Multiplication. So matrix multiplication works in a certain way that if there are two matrices, let's say this is one matrix, 1, 2, 3, 4, 5, 6. And let's say there is another one, 1, 2, 3, 4, 5, 6. So this is one matrix, right? This is one matrix. This one has 2 rows and 3 columns, and the second matrix has 3 rows and 2 columns. So there is a condition for multiplication. What is that condition? The number of columns in first matrix. So if this is, let's say, M1, and this matrix is, let's say, M2, then the condition, then there is a condition. If that condition matches, then only you can do M1 and M2. What is that condition? The condition is column of M1 should be equal to rows of M2. So this is the condition that we have to match. Otherwise, the matrix will, give you an error. So you following me? The first one has 3
You are hearing me?
columns. Hmm?
You can able to hear me, no?
Sorry, I did not get that. What was that?
You can able to hear me, no?
Yes, yes, I am. It's
Oh.
coming little slow, but just speak a little loud and it will be better.
Fine, fine. Because I'm using my headphone. That's why I'm this.
Okay, 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 no problem. So that is the thing. So for matrix, which are multi-dimensional arrays, the condition of multiplying two matrices are the columns of one of the first matrix should be equal to the number of rows to the second matrix. So here this is matching. So 3 is equal to 3. Let us suppose this matrix is like this. So in that case, how many rows it has? It has 5 rows and 2 columns. This will not work. So if I do M1 into M2, it will give me, Python will give me an error. It will say the matrix multiplication will not work. So that is probably the first thing that we need to check. And once that part is sorted, let's now go back to where we were. Yeah. Now, how the matrix multiplication works. The matrix multiplication works in a certain way that first it takes this value with this value. So how it will work? So it will work like 1 star 1 plus the next value in the first row, which is 2 star, the next value in the first column, which is 3, plus 3 star this value, which is 5. This will be my first element, the first value of the matrix. Similarly, what will be the second one? So the second one will be like 4 star, sorry, here, 4 star 2. First element with first element, second element with second element, plus 5 star 4 plus 6 star 6. That's it. So are we left with any other multiplications? No, we don't have any other things to operate. So first this with this, second this with this. So that's it. We are done with it. So this is what we will be left with.
Okay.
So what essentially will be is these two. This will be the final matrix that I will get, which will have 2 rows and 1 column. So what will be the dimension of this matrix? So the dimension will be 2, 1. That will be the dimension. So there will be 2 rows but 1 column. So see, the original matrix 1 had 2, 3, and the second matrix had 3, 1. So 3 and 3 should match. Like the columns here and the rows here should match. If these two works, then only matrix will operate the multiplication. Now, what the final value will be based on this variable. So if you compute this value, what you are going to get 1 plus 6, which is 7 plus 15, which is 22. And this one will be how much? Or just put an equal to here. No. Yeah. Just put a equal to here. That's it. So 22 and 64. This will be the new matrix that I have. So that is how traditionally we do a matrix operation, matrix multiplication, and these are very much important for images whenever you are doing an image processing or something like that, right? So this is all about a matrix multiplication. Now the important thing here is if we go back, the column should match and all of that conditions will it will be like that only. Just that if you do it in Python, you have to take care of the loops. So I'm not really going into the details because it will be too much of a complicated thing, but just that remember the loops. So what loop you need to, operate so that you can access these elements. And so the first one should be multiplied with this, the second should be, so you have to take the elements accordingly. So if let's say I run a small loop for I in range of length I in, just directly put the this name in matrix print I. So okay, one thing, the length. Okay, there are a few things that you need to check. If I put a length of the matrix, it's not working because this is an array. Okay, this is not defined. Sorry, matrix one. Yeah, the length is showing 2, which is number of rows. For this one, this is 3. So this is just the number of rows. So it needs to be operated those many number of times. So if I put the loop, so just remember the condition we used to have like this, and how we used to access the elements, matrix within square bracket and matrix, let's have it 1, matrix 1, and within that I. So if I do this, yeah, it's going to give me a lot of informations. Now, this is not how I wanted this to come. I wanted to access only one particular element at a time. For that, what I have to do, I have to play another loop within this particular loop. So the first loop, what it will do, it will operate on the rows. So the first loop will operate on the rows. The second loop will go through within one loop, then first element, then second element, then third element, like that. So for J in range of matrix 1 dot shape. Now there is, now this is unnecessary. That's why I wanted to avoid it. Matrix 1 dot shape. So I wanted to have 2 here. So how will I get that? Yeah, 3. So the second loop has to be iterated thrice, 3 times. So that's what I have to put it here. 1. So this value will be 3. So it will happen 3 times. And then if I now do this print thing, print of I comma j, let's say if I do this now, matrix 1, now I am able to access all the elements one at a time. 1, 2, 3, 3, 4, 5. 1, 2, 3, 3, 4, 5. So if you put something like this, then it will clearly tell you where are you. So print inside J loop, and if I go outside, so now I'm inside the I loop, because the J loop, see the indentation. So whatever you do inside this part, so that will fall under J loop. But if you come to this line close to 4, the J loop, it will be outside the J loop. So whatever statement is there. So if I run this, see, first it is going inside J loop. Let's put it here. Yeah. So first it is inside I loop. Now inside I loop, it is going into the J loop first. Then inside J, it's printing 1. So inside J, it's printing 2. So J is basically your column. This will be your column loop, and this will be your, this will be easier now, easier to understand. So now inside column, I'm accessing the elements. Then again, I'm outside inside the second row. Now that I am accessing these columns, 3, 4, 5. So that is how we can access each and every element of a matrix, right? So what we have to do here now is we have to come up with this particular logic. First element with this, second element with this, third element with this. So the logic has to be written in certain way that, so if I have to access this particular element 1. So this will be I comma j, right? Now ij in such a way that this I will remain same. This I will remain same, but the j will change. First, for all the situations, I will remain 0. But for the very first instance, your j is equal to 0. That I0, J0 will take this value. When I'm moving here, what will happen? It will take I0, but J will become 1. If I move to 1 right, J will become 2. So this will be my condition. And if I come here, here also same thing. I0, J0 for the first one. For the second one, I will become 1 and J will remain same because the column is same, just that the row value is changing. So this will be my logic. So this will be multiplied with this will be multiplied with this will multiplied with this, and then you take the addition. That will be the first element, 22. So you have to play your loop accordingly. The loop has to be played in a certain way that this value should be multiplied with this and accordingly. So is it making sense or is it like too much?
Yeah, yeah. Oh,
Okay. So that's about matrix multiplication. So I'm not going into much details now because as I told you, that will be too much of a thing. But just understand how the logic works and how we have to deploy two loops to access this particular matrix. One to access the rows, one to access the columns. That's it. Okay, that will be it. Now, let's jump directly into pandas because essentially that will be the most critical thing. Pandas. So the other day we were just talking about a little bit about the packages. So can anyone tell me what is pandas? Just quickly.
the library used working in datasheet.
Just a little loud, Ranjit.
Library
Hmm.
used for working in datasheet.
Yes, absolutely. A library where you can basically to do EDA. So this is a new term. EDA. What EDA stands for? Exploratory data analysis. Exploratory data analysis, or in short, we call it EDA. So what is that? So basically, we bring in any outside data into Python, and with the help of pandas, we can do this exploratory data analysis. Exploratory means to explore that data, to understand the data, how many rows it has, how many columns, how many of them are numeric, how many are character, what is date time, right? What is the sum, what is the median, all those things. And data analysis is essentially to understand the data and to talk about what that particular data talks about, like what is there any hidden meaning, what is the data refers to, and those kind of things. That is what EDA is all about. So that's what pandas does. So how do we import it? A simple import pandas as PD and just run it for the very first time. It might take a couple of seconds. See here the star on the extreme left hand side. Yeah, it's done. And for the next time, if you run it, it will just take a moment. So this is what pandas is. A powerful data analysis and manipulation library for Python. So if I have to put it like this, yeah, this will be the definition. So all you need to do is just click on PD and shift tab. That will talk you. See, it also tells you where this package is installed, which location. Pandas is it just gives you a brief idea of it. Uh, Expressive data in real world it has this, okay. Mm, yeah, these are few of the important things that pandas can do. Easy handling of missing data in floating point as well as non-floating. Size mutability. Mutable means things which can be changed, and immutable means things which cannot be changed. So columns can be inserted and deleted from data frame. So these are few of the things. These are few of the things that it can do. So it has a wide range of data accessibility. So pd dot, if I just do read, just see what are the things it can do. Clipboard means something which is copied and pasted in a normal desktop, in a normal, documents. We can get that information. CSV, Excel, we have seen. HTML, JSON files. PKL is something that we'll talk later. This is very interesting. SAS, if you know, SAS is a statistical software for analytical work. SPSS, SQL, it can take directly SQL queries and run them, and XML. So these are the different ways of inputting data into Python. So it has its immense application, but for our purpose, for all of our operations, majorly we will be using this. Uh, let's see. Yeah, let's try that. This is quite simple. Foods. So all you need to do is pd.read CSV. Here, the first argument will be your location with the file name. This. And also you have to specify the file name. So just foods.csv. That's it. That's all you need to do. Now, this is the mandatory one. Now, it has a lot of optional fields. So if you go here, it will tell you what are the optional fields here. So the first argument is file path. Then there are separators. Separator means for our case, the default is a space. So we don't need to do anything. So if we had other separators like, a particular star or a plus sign or something like that, then that would have been different. Delimiter, header, names, engine type. Now, by default, it's a CSV engine, so we don't need to specify. But if we have to include Excel, now Excel has a lot of upgradations, right? Excel 97, Excel 2003, Excel 2010. We have to play around with this engine accordingly to get the right values. Skip rows will just skip first 1, 2, whatever number you specify. And these are the different things. So it has a lot of, detailed descriptions of what all those fields are and what all they're doing. So if I run this, okay, I'm getting an error. Now, other day also I told you, you might get this Unicode error. And nothing to worry here. All you need to do is just put R here at the starting of it. If you put R and run, yes, this has worked. Now, this is a data frame, DF. DF is a data frame.
R stands for what?
Sorry?
R stands for what? Why we are putting that R?
So R is basically to tell, to tell Python that, or to tell the Windows that we are incorporating this whole thing as the path. Usually, we are supposed to have, so usually computer reads in this way. From terminal, if you read anything, it reads in this way. This is the ideal format of reading something. But for our case, the format is little bit different. So we have to tell Python that don't treat it as a different, rather treat it as a normal input file location. One second. Can you see the difference between what we have written and what is coming here?
Yes, yes.
That is the ideal way of telling a computer that this is what you should, you should have, or you should write. So, long story short, understand, just to solve the Unicode error, because this is a common error, and also there's one more thing, the Pandas package that has been upgraded after that. So there has been some upgradation, and post that this is what the way out to solve this particular problem. So just put R here and just it will give you the data frame. So this is a data frame. We call them data frames. So this looks like Excel's, right? It has rows and it has columns. So 0, 1, 2, 3, 4, these all are rows. And these all are columns. 1, 2, 3, 4, 5, 6. Now, if you want, now it's giving you everything, right? A lot of information. If you want to see just selective information, so there is a command called head. So it will give you top 5. It will give you top 5. Now, if you put any number between head, this function, it will give you those numbers. Let's say I just want to see the top 2. So I will just put head 2. Or if I want to say the top 9, I'll just write like this. So this is head, same goes for tail. Tail will fetch the, the bottom 9 rows from the bottom. That's what head and tail is all about. Then we have, I just want to know how many rows and columns it has. We have already seen that, which is shape. It has 1,000 rows and 6 columns. So that is on shape. Okay, I need to know about the columns. There is something called info. So, like this. Yeah, this is better. So, df.info will tell you information about each and everything. So, it basically tells you the first column has non-null values. That means there are no null elements in it. And they are all object. Now, object means this is character, a string. So the data type is an object. Similarly for gender, gender has 1,000 records and they are non-null. That means there are no null or missing values in this all 1,000 entries. And that's also object, means it's character or string. Same for all of that except the last one spend, which is same but it is float 24. That means this is it has decimals in it, 98.61, this and all that. So that is the info. And there is one more important thing that we do very rarely, which is describe. So what describe will do, df.describe will just give the basic statistical outcomes or the basic statistical measures of these numerical. It will consider only the numerical ones. See, I have only one numerical column. That's why it's considering only that numerical column. So what are the things it's telling me? Count number of total number of entries, which is 1,000, correct. The mean. Mean is the average. The average value of all these entries. So spend, it is something which people have spent, right? Amount spent in dollars or rupees or something. So the average expenditure is 50 rupees. Standard deviation. Standard deviation is 27.7. The minimum spend is 1. Now these three are known as percentiles. Not the last one. This is the maximum expenditure by one single entry, which is 99. Now these three are the percentile. So this tells you first 25% has how much of the overall spend. Then 50% is the next 50% of the entire crowd is spending how much, and the last one, so on and so forth. So like that. So these all are your in percentile. So that's what this describe will tell you. So df dot describe, it will work only on the numerical ones, and it will tell you like what are the things that this has done. But what about the characters? Now first name, there is no point of doing any analysis on this one because first name could be anything. So if there are 1,000 entries, you might get 1,000 different names, right? So we cannot tell for sure based on a name of a person, but based on gender, we can probably do some interpretation. Like if the gender is male, the expenditure will be more. or the gender is female, expenditure will be less, or we can probably, based on our understanding, we can do some sort of assumptions. So how can we do that? Okay, so before that, just understand how to access a particular column. Now, this is a data frame that we have seen. This is a data frame. Now, how to access a data frame column using square brackets, and within that, just put the column name. That's it. So that's how you can access a particular column. Now, within that particular column, what we have to do is we have to do value counts. So if I do this, it will basically give me a split of those 100 records for that particular gender. So gender has female and male. So I could see there are 512 females and 488 males. So more female entries. So there are further options that you can do. You can do sort this out. Let's say you want to save this result into somewhere else. So you can sort them up, you can, do anything out of it. We will just do normalize. So what normalize will do, see here, if I put normalize is equal to true, it will just give me in percentage. It is just giving me in, so normalize as in like it will just give me the value in 0 to 1, which is essentially in percentage, but 0.512 is essentially 51.2%. But we can make it better using star 100. So just multiply it by 100. That's it. So now this is much more clear. So this gender, out of this gender, 51% are female and 41% are male. So can we do it for other things? Yes, absolutely. Let's access the columns first. df dot. Okay, at any confusion, just do this. Just do this. It will show you all the probable and possible options that you can do it, play around with. So I would be needing the column names because right now it has 6 columns, but imagine situations where we might have lot of columns into it. So I can access all the columns through df.columns. Now see, this is coming in the range of a list, but the whole thing is a tuple. That's what it looks, right? Single angular brackets are for tuples and square brackets are for list. Let's see what is the data type. Let's see the data type. So index pandas core, it coming as a series, but okay, let's store it somewhere. X is equal to this, and then type of X going to give me the same thing, but what if I access only this value? So if I do this x0, the first element, I would have options to access in this way. df dot, okay, let's see if len works. Yes, length works. So all we can do is for I in range of length of this, that same thing, print of what? Print of df dot columns square bracket I. So these are like different means how you can access column. So using a loop, now I'm accessing a data frames columns. See how all are interrelated. So gender we have seen. Let's try out city now. Let's try out city. Yes, 35.9% from Philadelphia, 32.8% from Stanford, and 31.3% from New York. Great, this is working. So what if we have to do it for something else? Gender frequency. Let's first see. Yeah, frequency will also work and item will also work. So this is, or you can just copy paste it from here. I mean, your wish. Okay, frequency, there are a lot of values here. Weekly, daily, once. So best would have been to sort it out. See, by default comes as in sorted. Now we can just change the sorting order from ascending to descending. See, ascending is the sorted order. So, so by default it's coming in a sorting, in a descending order because the ascending value is false. Ascending false means by default it's giving you in a descending order, and sort is true. So by default it is sorted. So if I want to change it, I will just put ascending is equal to true. What it will give me? So this will give me the same in a reverse sorted order. So that part is done. Now, after frequency, what we had? Item. Let's see what are the different items we had. Yes, these are the different items we had. So like donut, ice cream, burrito, sushi, burger, and something chalupa. So these are the different food items. So what we are doing now essentially is EDA, right? What we are doing now essentially is EDA. We call this EDA because initially we had this data set, this CSV file, some food related CSV file. We had no idea about the number of rows, columns, anything. We did not know anything, right? We did not know anything about it. But we rather brought this into the Python framework and we started exploring things into it. We started exploring their data types, their missing values, their different features, what other different columns are, what values they do have, how much of the percentage, if it is more or less. So those are the type of things. So we can do with the help of a pandas and EDA is all about. So that is one thing. Now, what if we have to create a data frame on our own? This is what a data frame readily we just imported a file from outside and pd.readcsv will by default create a data frame. That's how the pandas library is being written. What if we want to create a data frame on our own? Okay, let's try that as well. Let's try this here. Data frame creation. So how can we create it? df is equal to, okay, see the name. We already have something called df, right? So if I create a new df, that will basically override the older one. So if I don't want to hamper the older one, I should use a new name for the new data frame. As simple as that. So how do we do it? Using pd.dataFrame. So this is the class it has now class. So I'm not going to into the details. Essentially, this is one mode of creating. So pd.dataFrame. Now within that, you have to put some values. What values? Just do shift tab. It will tell you. First, it is a data unit and index and columns and d type and copy. So these are few of the things that needs. Whenever it's blue highlighted, that means these all are optionals. If you put something, fine. Otherwise, it will be replaced by some value, some by default value. But data is equal to none. This is a mandatory field. You have to write something. So the first thing is index. Index is what? Index is the position that we have already seen in list or tuples. Just that here in a data frame, we can see that index as well. In list, tuples, arrays, the index was not visible to us. So we had to assume based on the mode of operations, we had to assume that the first position was 0, the second was 1, the third was 2, and so on and so forth. But in a data frame or in pandas, it will show you the index also. So instead of this tail, if it had head, this would have been the index. It starts with 0, 1, 2, 3, 4. So that is what index is all about, the position. Columns are the column names. If you put, let's say you want to create a new data frame. Now you have to, if you specify the column names will get, will take the values from you. Otherwise, it will be created by some random column names, call one, call two, something like that. Now the important question is, so these are the two things. D type is the data type, and yeah, that's it. And now the important thing is data. How can you create a data? Do you want to write it? Yes, we can certainly, if you want, we can write it, but that would be too much of a thing. If you want to write some values, that will be too much of an information. So the easy workaround that we always do it, we create a dictionary and we put that dictionary inside the, into the data frame. So how to create a dictionary? This is how we create a dictionary within square bracket. First, there is a key and then there is a value, right? And then there is another key, there is another value. That's how we do, right? So let's try that. Let's say name. This is the key. My key is name. And what are the names I will have? Let's put some names here. This is the name. So this is one dictionaries, this is the key and these are the values. Similarly, if I have to put something like this, let's say location, key, colon, and then after colon, I have to specify the values. So Ranjit is from Chennai. And CN, where are you from? You said Hyderabad.
Kerala.
Oh, Kerala, sorry. So if I do this, for now, let's hide this. Now, at any position, if you want to hide a line, just put a hash sign. So this will just not execute this particular line, will not be executed. So this is a dictionary. So if I want to see it, dict, run. Yes, I can see the dictionary. Now, are we sure this is a dictionary? This is just a cross check that you can do it from your end. Yes, this is a dictionary. So my dictionary is ready now. So if I want to create a data frame out of it, I just need to pass that whole dictionary through here. That's it. And df1. Now, if you want to write print or whatever, or if you want to write just df1, this will also work. This will be a data frame. So that is how we can create a data frame. So this will help me to create a data frame. So see the alignment. So the first element is going to the first, the second is going to the second. Let's say we had a different one. Now, these are few of the things that you should just try it out on your own. And this will tell you what will work, what not will work. So if I run this now, it's giving me an error. What is the error? Let's come down and see what the error is. It says all arrays must be of the same length. That means all of these elements should match. Let's say if I put this as UP and if I run it now this will work because now the item numbers are matching. Here it has 3 items, here it has 3 items. So essentially it has to do that one-to-one join, right? It will align Ranjit with Tamil Nadu, Sian with Kerala, Ram with UP. That is what it will do. So, and that we have to ensure that this alignment is correct. Let's say the input data has, Kerala, then UP, and then Tamil Nadu. Then Python will create it wrongly. So we have to ensure that the input that we are providing is correct. It aligns, with the input names or with the other columns. So it will just create the structure. It will not do anything intelligent on it. It will just create the structure for it. So that is how we can create a data frame on our own. Now, let's say this is a list, right? So we have this list separately. That will also work. Let's say this is L1, some other list. So instead of writing it, all we need to do is just call that list. Just call that list and it will just add all those values here. So these are ways through which you can create a data frame on your own. Now, here, one more thing which I missed. There is something called a series. Something called a series. Now, this is not of major importance, but this is just like a good to know fact. So, let's say you have one dimension, you have value only one, or let's say, let's remove this. So, this is a one-dimensional data frame, right? This is a one-dimensional data frame. So this has only one column into it, but it is getting stored as a data frame. Instead, Pandas has something called series, where for situations where we have data in only one dimension, like one column, something like that, to solve those kind of situations, what Python does is puts them into a series. Now, what it does, so this is like just single one-dimensional array or a single column. So like, let's say X is equal to, or let's say L1 is equal to, this is a list which has 3 values into it. This is a list. Now, what it will do is, so let's say var is a variable that I'm creating. So pd dot series, and within pd dot series, what can I do? You have to put the data. So if I put the data here, L1, and see the outcome, yes, this is series. This is a series. So this is a data frame and this is a series. Now this also has index. By default, it starts with 0, 1, 2. If you want to change the index, you can just add some of your random values. Let's say A1, let's try this out, A2, A3. Yeah, this is the new index that I've created. So indexer means to access element, but just see the difference. Series are just one dimensional. It cannot be two dimensional. So what if we try to create a two dimensional thing? So if we try to create something like this, it will throw an error. Length of values 2 does not match index 3. Okay, no, that is the, let's drop the index and then try. Let's see if it still works or not. Yes, but essentially see what it is doing. It is treating this whole thing as one element. Essentially, it's treating this whole thing as one element. It's not treating them as 3 elements. Like we were seeing here, Ranjit is different, Tamil Nadu is different. But what is treating is, it's considering this whole as one single element. That is the thing. So everything will be in one dimension. That's what series are. Now then, what is the difference between series and pandas? So essentially, as let's see, as far as I can remember, I think it's just the memory. Yeah, a data frame can store more complex and heterogeneous data. Heterogeneous means something which is of different data types, while a series can store more simple and homogeneous. Let me just take this. I was just trying to recall this and I was not able to. Can store while series can this data frame can access. This means that a data frame can store more complex and heterogeneous data. Heterogeneous means things which are of different data types. Like we have seen here. So it's only two, but it could have been an integer, it could have been a date time, it could have been a mix of everything. So that is a heterogeneous mix of everything. Homogeneous means only one type of data, either numeric, either character, either text. While a series can store more simple and homogeneous, another difference is that a data frame can have different data types for each, while a series can have only one for the whole array. So that is the basic thing. Now, series is not something that we will use in a day in day out basis, but data frame is something that we will use regularly in a real world practical situation. So that is what you know this thing is it's all about. So that's all about series. So series, I mean, sorry, that's all about data frames. I mean, it's about storing new things. It's about storing different data types together. Now, next important and crucial part would be to access it. So we have just seen the basic things, right? What are the different functions, how to access different columns. Those are the things that we have seen. Let's say df will give me everything. I need only first name, so this is what I will do. First name, it will just give me first name. What if I need to have this in a data type format? So I just have to put another square bracket here. Now it will show me in a data frame format. Now just put head to limit the number of records, put 10. And now let's say with head, I need to know the item also. So within this comma, I will just write item here. So that is how we can access individual columns within a data frame. Now, an important thing would be to be able to access specific elements, within a data frame. So that is something which we can so Ranjit and Sian, if it's okay if we can do it tomorrow.
Yeah, no problem. That's okay.
Yeah. So tomorrow what we can, so today we have seen the basics of
Data.
a data frame, how to import and the basic things that we can do. So tomorrow, what are the things that we can do is we can probably see how to access individual data elements, how to access individual rows, individual columns, how the index is beneficial to us. Do we need index at all or not? How to sort, how to group by, and other multiple functions of a data frame. So those are few of the things that we need. Suppose we want to know all the, all the rows where item is burger. How
Okay.
to do it? How to have that filter? Then suppose we will see how to see how to see the spend of ice cream. So what we have to do is first we have to filter all the ice cream rows. Let's say there are 200 rows where or here we have seen, right, how many has ice cream. Ice cream has 17%. So roughly 20% of 2000 records. That will be your ice cream. So first we have to filter them out and then we have to sum the spent amount. So that will tell me for ice cream how much people have spent. And so those kind of scenarios are something that we can probably explore tomorrow and do more of coding.
Okay.
But just tell me, like, is it relatable? Like, is it like confusing like arrays or like it's still better?